Hello everybody, my name is Aedan Maloney, and today we are going to be going over this statics as well as material science problem. Our goal for this problem is to be able to find out what the internal stress of rope AB is equal to when force P is applied on this system. Our knowns for this problem is that the diameter of rope AB is equal to 5 millimeters and the force P is equal to 750 newtons. Drawing up our free body diagram, which we learned back in statics, we're able to come up with this system. To be able to find out what force AB is, we're going to be using some of our static equations. Well, actually, in this case, only one, that being the summation of moment. If we take the summation of moment about pin C, we'll be able to calculate what force AB is equal to. Knowing that force P is 300 millimeters from pin C, and that force AB is 125 millimeters from pin C, we'll be able to plug him in to our summation of moment formula, where the summation of moment is equal to 0, is equal to negative P because he's creating a clockwise moment around pin C, times 300 millimeters plus force AB because he's going to be creating a counterclockwise moment around pin C, times 125 millimeters. We're able to come up with that force AB, once we plug in P, is going to be equal to approximately, actually exactly, 1,800 newtons of force. Now, remember, in our strength of materials, we need to find out what the stress on rope AB is. So how do we do that? Well, back in our strength of materials, we were given this formula where stress is equal to the applied force divided by its area. Well, we already know what force AB is, and now we just need to find out what area AB is in order to find out what the stress is on that rope. Now, we already know from high school geometry that the area of a circle is equal to pi divided by 4 times the diameter squared. So let's quickly just type that in. We already know that the diameter of AB is 5 millimeters. So once we plug them into this equation, we should come out with that the area AB is going to be equal to 19.63 millimeters squared. So let's just quickly now plug area AB into this equation. What we'll come up with now is that the force AB divided by the area of AB is going to be equal to the stress, is going to be equal to 91.67 newtons per millimeter squared. Or, because this is a stress, we're going to be dealing with pressure, is equal to 91.67 megapascals. Because megapascal, as we already learned, uses the units Newton divided by millimeter squared.